Welcome to Transformations Reflections. A quick little review about reflections is that reflection does not change the size of the image. When the pre-image is being reflected across a line, the distance from the pre-image to the line and from the line to the new image will stay the same. So let's start off with this parallelogram that we have in number 1. We're going to reflect it over the x-axis. So let's start off with labeling the points for A, B, and C. So here's A will be -1, 4, B will be 5, 4, C will be 2, 2, and D will be -4, 2. Now, when you're reflecting across a line, so we're reflecting across the x-axis, right? So when we reflect across the x-axis, we need to measure the distance from the point onto the x-axis and then go the same distance away from the x-axis. So let's do that very slowly. So let's look at point A. Point A is 1, 2, 3, 4. 4 spaces away from the x-axis, the line of reflection. So that means that on the final image, it will also be 4 distance away from the red line. So 1, 2, 3, 4. Let me put that in a different color. So my A prime will be -1, -4. Now let's go ahead and let's do D, or actually let's do B. So B is right here. I put it with this orange dot. And I'm going to count the space from B onto my line of reflection. So 1, 2, 3, 4. If it's 4 distance away from, if the pre-image is 4 distance away from the line of reflection, that means the distance from the line of reflection to the new image is also 4. So 1, 2, 3, 4. So my B will be at 5, -4. Go ahead and find me the coordinates for the new coordinates for C prime and D prime. Alright, so you have your coordinates for C and D. Go ahead and check your answer with mine, please. So from C, I am 2 away. That means on my new C, I'll also be 2 away. So I will be at 2, -2. And for D, I am also 2 away. That means I'm going to also be 2 away from the line of reflection, which will put me at -4, 2. Do you see a pattern in the coordinates? So look over here. Look over here. What pattern do you see? Take a look and think. Here's a little hint question. What stays the same? What changes? And how does it change? Alright, so I'm going to tell you that I see that the x value stays the same. So these x values stay the same. Ooh, that's way too big. These x values stay the same. So I can say the x values are the same. And I'm also going to notice that, hey, my y values are close, right? My y values look very similar. But what is the difference? That is correct. The difference is that it is multiplied by -1. So the y values are multiplied by -1. So for example, I went from 4 to -4. I went from 4 again to -4. 2 to -2. 2 to -2. So the rule for the reflection across the x-axis is from x comma y. This becomes x comma -y. Alright, let's do it across the y-axis. So I'll give you the coordinates for the points now, and then why don't you try to do this reflection across the y-axis all by yourself. So x is currently at -7 comma 5, y is at -2 comma 8, and z is at -6 comma -6. And we are reflecting across the y-axis. So here's your y-axis. Make sure you make that nice and clear. Go ahead and give me the new coordinates for x prime, y prime, and z prime. Alright, you've tried drawing it on your own. Let's see if we could do it ourselves. So the new x coordinate should be at 7 comma 5. The new y coordinate will be at 2 comma 8. And the final new z coordinate will be at 6 comma -6. So that's 7 comma 5. We have 2 comma 8. And then we have 6 comma -6. And that will be the coordinates of our of the image. Alright, so again, what is the pattern in the coordinates? What do you see? Go ahead and respond and look at your neighbor's response or your discussion board. And let's write the rule for a reflection across the x-axis. So we're going to go from x comma y to, that is correct, -x comma y. The y values stay the same, but the x values are multiplied by -1. Alright, good job.